In this tutorial, I'm going to discuss a programming question, sort characters by frequency. So the problem statement is given a string, sort it in decreasing order based on the frequency of characters. So we have to sort a string based on the count of characters, and let's see some examples. So in the first example, the input string is tree, and in this string, E appears twice, T and R appear once. So it means we have to put E first, then RT or TR. I mean, both the output are valid. So R and T have same frequency. So either you can put R, then T, or you can put T and then R. So in the second example, in this input, C and A appear 3 times. So either this output or this output, both are valid as both the characters have same frequency. And in the third example, the input is capital A, then small a, and B, then small b 2 times. So it is clear that we have to put B first, then capital A and small a, or B first, then small a and capital A, as both the characters have same frequency, and the capital A and small a both are different. So you can't count A has 2 frequency. No, it's not. The small letter A has 1 frequency. The capital letter A has 1 frequency. So both the characters are different, and this output is invalid. So please keep this point in mind. Now we have seen in the examples that how in the output we have returned a string which is sorted by the frequency of characters. So this is the problem statement, and now let's discuss multiple approaches to solve this problem. Let's discuss our first approach to solve this problem. So in this problem, we have to sort characters by frequency. So to sort them by frequency of characters, first we have to know each character and its count. So in this string, first we have to find each character and its count. It means we have to traverse this string, and we have to keep this record that this character has the count of 1 or 2 or whatever it is. So we have to put somewhere each character and its count. So for this, the ideal data structure is map. So you can use hash map to keep each character and its count. So here what I'm doing is I'm traversing this string, and then I keep each character and its count in a hash map. So let's traverse this string, and the first character is T. So then I'm checking in a hash map whether this character is present. If it's present, then give me its previous count, and then I add 1 to it. Else I put T and its count 1. So in hash map, we simply keep key and value pair. So in simple words, we keep key and value pair. So in this case, key is the character and value is its count. And also in hash map, key is always unique. So now the next character is R, and again I'll check is R is present in a map. If it's present, give me its previous count. Else we put this character R and its count. So its count is 1. So you can see this line. So here we are keeping the record in a hash map. So key is character, and in this map we are checking is this character is present, get or default. It means if it's present, then give me its previous count, else the default value is 0, and then I add 1 to it. And then the next character is E. So first time, so it's not present, so we put E and its count 1. And then when again the E occurs, we check is it present in a map. So give me its previous count. So its previous count is 1, then I add 1 to it. Now it is 2. Now we know each character and its count. After this line of code, we know each character and its count. Now let's sort this hash map by its values. It means by the character count. So in hash map, we are storing key and value part. So value is the character count. So if we sort the hash map by its value, then the record will be arranged like this: T, E, the value. So this record will come first, then R or T, or maybe T or R. So I mean, it doesn't matter if either R comes first or T comes first. So let me write it T1 and R1. And then if I iterate this map and I append E twice, then T once or R once, so we get the output. Or if it if instead of T, if it is R here, then it will be E, R and T. So both the output are valid. So now the problem is solved. So here is the code for sorting this hash map, then iterating this hash map, and we take each record and then we are appending the character by the number of time it occurs. So this is the Java 8 syntax. Here we are taking a key and value pair, and then we are appending the character number of time it occurs in this string, and then finally we are returning the result, which is either this string or this string. So now let's talk about its time and space complexity. So its time complexity is O and log n, as we are sorting the hash map by passing a comparator. So, and what about its space complexity? So we are using additional space, so its space complexity is On. Now let's discuss our second approach. So instead of sorting the hash map, what we can do is we can use a priority queue to solve this problem. And I hope you are familiar with queues. So a queue is a first in first out data structure. So the element which we enqueued first is the first element to be dequeued. And how priority queue is different from queue? So in priority queue, each element has some priority associated with it, and the element which has highest priority is the first to be dequeued from this priority queue. So in priority queue, while creating this, instead of priority queue, we are passing the custom comparator, and we are saying the character which has highest frequency. Give me the character first which has the highest frequency. So we first create a hash map of character and its count. So we first put all the character and its count in a hash map. So I have already explained this process, how we are putting character and its count in a hash map. So this this process is clear. I mean, you are familiar how to create how to put character and its count in a hash map. Now, so let's create a priority queue, and in this priority queue I am passing a custom comparator. So this is Java 8 syntax, and here, so now we know each character and its count as we have already created a map. So by using this, I have written this comparator. So it means when we add all the characters in this priority queue, it will arrange the character in such a way that the character whose frequency is higher, which has highest frequency, it will come first. So once we added all the characters in this priority queue, then simply traverse this priority queue. So when we traverse this priority queue, and when I remove the character, so this will come first. So E has the highest frequency, so it will come first. Then what we do is, we know so when we check them in a hash map, we know its count. So let's run this loop 2 times. So its frequency is 2. So let's run this loop 2 times and append them in a string builder. So we append E twice. Then either T or either R, anyone will come after E. So let's say R will come. Then we run a loop once and we append them here. Then T comes, we run a loop once and we append here. And we know that here either R or T, both are valid. Both these output are valid. So after that, we return a result. So let's quickly revisit how we have solved this problem using hash map and priority queue. So first we have created we have put all the character and its count in a hash map. Then we have created an instance of priority queue, and we have passed a custom comparator in which we are saying, give me the character first whose frequency is maximum. And then we add all these keys, all these all these unique characters in this priority queue. So we know only these characters are present in this string. So we add all these characters in a priority queue and it will arrange like this. So imagine this in a queue. So E will come first, then either R or T. So let me write R and then T. So now when we now let's run this loop, let's run this while loop until this priority queue is not empty. Then we remove so when we dequeued the character from this priority queue, first E is removed and then we check its count, its number of occurrences in a hash map, and its number of occurrence is 2. So we run a loop 2 times and we append this character in a string builder. Then in next iteration R will come, then we append R, then in next iteration T will come, then we appended T once, and after that the priority queue is empty. I mean, we have removed all the characters from this priority queue. So we came out of this loop and then we return the results. So by the way, this is max heap implementation, and in this tutorial I'm not going to discuss max heap implementation. We will discuss it separately. And now let's talk about its time and space complexity. So its time complexity is O n log n. So we are using the priority queue and we are passing custom comparator so that it will arrange in such a way that the character whose frequency is maximum will come first. So that's why it is O n log n. And what about its space complexity? So we are using extra space, so it is O n. Now let's discuss our final approach in which we will solve this problem in O n time complexity. In this example, I'm going to discuss how we can solve this problem using hash map and bucket sort. So the first step is to put all the character and its count in a hash map and also keep track of maximum frequency. So this character has the maximum frequency, which is 2. So the maximum frequency is 2. Now let's create a bucket of size max frequency plus 1, which is 3. So let's create a bucket whose size is 3. So it means 0, 1 and 2. Then what we have to do is we have to put the character based on the frequency. So I mean, this bucket index correspond to the frequency of a character. So we have to put the character in their respective bucket. So and this bucket is a multi-storage bucket. It means if the multiple character has same frequency, then we can put them in a same bucket. For example, so let's see. So the E has frequency 2. So we have to put this character E in this bucket. Now the R and T has the frequency 1. So we have to put both the characters in this bucket. So let's say T, R. Then now we have put all the characters in their respective bucket. Then traverse this bucket in reverse order, in descending order. So we have to start from second index. Then we have to take this character. We know its count. Its count is 2. So it means it has occurred twice. So let's append 2 times. Then we can pick any character in any order. I mean, out of T and R, either pick T first or either pick R. I mean, it doesn't matter. So then we take this character T, its count as 1, so append once. Then take this character R, its count as 1, append 1. So this is the logic behind this approach. Now let's see its Java code, and now let's discuss its time and space complexity. So here I'm creating an instance of string builder, and also I'm creating a map of character and integer type. So this I have already explained in previous 2 examples. Now let's revisit again, and then I'm declaring 2 variables, which is max frequency to keep track of max frequency, and frequency to count the frequency of each character. So then I'm traversing this string, and in this frequency variable I'm storing the frequency of a character. So the first character is t. So so initially when the hash map is empty, t is not present in a hash map, so we get its default value. So get or default, either we get its value from a hash map. If it is not, then we get its default value, which is 0. Then I add 1 to it. So then we put this character t and its frequency, which is 1, in this hash map. In next iteration r, similar case with r, then e, similar case with e. Now when the e comes again, it means, so the previous count of e is 1, so we get 1 from this hash map, and then we add 1, so the new frequency is 2, and then finally we put e with the frequency 2. And also we are keeping track of max frequency, so we are taking the maximum of frequency and max frequency. So the initial value of max frequency is 0, so till this element the max frequency is 1. So when the frequency is 2, we are checking the max between 1 and 2, so which is so the max is 2, so the value of max frequency is 2. Then we are creating a bucket of size max frequency plus 1, which is 3, and this is a multi-storage bucket. So in each bucket we can store multiple characters whose frequencies are same, as I have already explained. So that's why we are using list here, list of character array, and this corresponding bucket index. So the bucket index is corresponding, so it represents the frequency of characters. So that's why we are keeping track of max frequency. So if the frequency of character is 2, it means we have to put in a bucket whose index is 2. If the frequency of character is 1, it means we have to put in a bucket whose index is 1. So here we are doing that. So what I'm doing is, so we are traversing, so we have take this key set. So it is a set of keys. So which a set of keys, it means all unique keys. So I mean in hash map the keys are always unique, so it will give me this set of character type, which is the set of keys. Then we are traversing this keys. So the first key is, let's say, so the order, so in hash map the order is not maintained. So when you traversing this set of characters, either t comes first, r comes first, or e comes first. So now let's assume the t comes first. Then we are checking its frequency, which is 1. So here we are checking in this, so we go to that index, and if it is null, it means we have not put any character at this bucket. So we are initializing with array list. It means we can store multiple characters there if they have the same frequency. Then we are adding this character. So t is added at this so in this bucket, so in t is added. Then the next character is r, and this time we have already put one character in this bucket. So this condition is false. It means one character is already present in a bucket, in this bucket, so it is not null. Then we add r as well. So we have list of characters in this bucket, and the next character is e. So no element is present at this bucket, so it is null. Then we initialize with array list, and then we add e in this bucket. So now we are done with this process. We have created a bucket, and we have put all the characters in their respective buckets. Now the next step is to traverse this bucket from the maximum index from this side. So we have traversing this bucket from second index, and we are checking if the character present at this bucket, if this index is not null. I mean we have put some characters in this bucket. Then what we are doing is we are taking the list of characters from this bucket, so we can store multiple characters in each bucket. So we are taking the list of characters, then we are traversing each character at a time. So in this bucket only one character is present, which is E. So we are taking this list of character in which only one element, only one character are there. So we are traversing this list and the character is E. So we are checking its count, which is 2. Then we are running a loop if its count is greater than 0, and then we are appending in string builder. So we first appended E, then it is still greater than 0, its count is 1, then we appended E again, and now its count is 0. So we came out of this loop and we goes to previous iteration, I mean this iteration, and we are done with that as well. So only one character is there. So we came out of this loop and then we move to this index, and here we have list of characters. We have multiple characters, which is T and R. So we get the list of characters. So first character we get is T, and now we get its count from the hash map, which is 1. So we get 1 here. So here I have put 2 semicolons, so please ignore 1, and then we run this loop until it is greater than 0. So the value of f is 1. Now we run a loop and we append T, and now its value is decremented and it is 0. Then we came out of this loop, and the next character is R, and so the value so we get its count, which is 1, and again we run this loop and we append this R, and then we came out of this loop, and also we came out of this loop as well. We have visited all the buckets. I mean after 1 we visited this 0 where we get the null value. So we have not put any character in this bucket, so we get null, and after that we came out of this loop as well and we return this string, which is eetr or eert. Both are valid, so we return any one of this output. Now let's talk about its time and space complexity. So its time complexity is O(n), and what about its space complexity? So its space complexity is also O(n). So in this tutorial I have discussed 3 approaches to solve this problem, and if you know any other approach you can let us know through your comment. And that's it for this video tutorial. For more such programming videos, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video, and please don't forget to like this video.